All right, in this video, we're going to look at the end behavior of polynomials. There's a lot of good information in this video, so make sure you kind of digest it a little at a time. So there's some key things to catch on this. The sign of your polynomial, that lead negative, will indicate the graph points down. So think of it as like slope. If it's negative, it's going to be like a negative slope. Or if it's an even power, it's going to be pointing down. So either way, it's going down. Now, the degree, remember, the degree is the highest exponent. So maybe you need to write that in there if you've forgotten. Highest exponent of the equation. If the degree is even, then the ends will stay together just like a parabola. So if you think about it, a parabola is x squared. It's an even-powered, it's the smallest even-powered polynomial we have. So it's going to think of it like a parabola. If the degree is odd, then the ends will go away just like they are when it's linear. So, and that's because our simplest odd function is just y equals x, okay? It looks like a line, right? The ends go in opposite directions. The number of turning points of the polynomial is always one less than the degree of the polynomial. So we're talking polynomials, we're thinking like roller coasters, okay? They go multiple directions. What we're talking about here is the end behavior. What would happen if I saw a graph that had lots of curves and turns, but if I zoomed out, I would recognize that the ends either go in opposite directions or they go in the same direction, right? So this is why we talk about the ends of the polynomials. Now, a notation. When we talk about the notation of our end behavior, this is what it looks like, okay? And when we read this, we read these lines right here as approaches. All right, so as x approaches negative infinity, well, think about your graph. Where's negative infinity? Well, that's over here on the left, isn't it? So make sure you realize that as it's pointing to negative infinity, that's saying as it goes left. And so then you have a second line, as x approaches positive infinity, that's to the right. So this would be as x goes right. That's another way we say it. And then you fill in which way is it going. Is it going to positive infinity or negative infinity? That's the way you end it, okay? So for example, let's just say I have a graph that looks like this. All right, so the way that I would answer this is I would say, as x approaches negative infinity, as I go left, the y, the graph, the y values are going up, which means it's approaching positive infinity. And then I do looking right. As x approaches positive infinity, y is approaching positive infinity as well. They both go in the same direction. So this is the way I would read the end behavior of that graph. All right, so let's look at these first questions here. It says state whether the function is graphed as an odd or an even degree, positive or negative leading coefficient. All right, so A is odd or even. So let's just look at that for a moment. Odd means they go in opposite directions. So I think odd, opposite, even, they go the same. Okay, so as I look at these, look at my sketch here. My ends go opposite directions, so that means that this one's odd. Number two, let's just do the A part first. They're going in the same direction, that means it's even. Number three, they go the same direction, so this is even. And number four, they go opposite directions, so this is odd. Now we go back and let's think about, is it positive or negative? So if I look at this slope, it's going uphill, so that means it's a positive. This one is going down, pointing down, so that means it's negative. Number three, it's going up, right? So that's positive. And this one is going downhill, so that would mean that the leading coefficient is negative. All right, that's the first skill you got to be able to do. Now let's look at this. For each of the functions, we're going to state the degree, the highest power, state the maximum number of turning points, sketch the picture, using infinity notation, describe the end behavior, and then sketch it. All right, so let's just take this piece by piece. Let's first just state the degree. Remember what degree means? It means the highest exponent. So look at number one. What is the highest exponent we see? It's right here. It's a 4. So if we do A and B really quick, we can. So if the highest degree is a 4, the maximum number of turning points is 3. Let's look at number 2. This one's factored out, so stop and think. If I multiplied all that out, this is x squared in here, times another x would mean it's x to the third, isn't it? So I have to be careful. So my degree is 3. That means the number of turning points is 2. Look at number 3. Now be careful. This one's not in exponent order, so you want to make sure you eyeball it. Make sure you get the right highest degree. So the highest degree is 6. That means the number of turning points is 5. Again, with 4, the highest exponent is not the first one listed, so I need to be careful. This is 5, and that means the number of turning points is 4. Okay, so let's go back and do the next part of this, all right? Next, C says, sketch a picture of the parent function that it mimics. All right, so if it is even, remember, if it's even, it's going to mimic the parabola. Number 2 is odd right here, so it's going to mimic the line. Number 3, it's even, so it's going to mimic the parabola, but notice that the coefficient is negative, right? So it's going to go down. It's going to open down. This one has odd, but it's negative, so it's going to go like a negative slope. Okay? All right, D, using infinity notation, describe the end behavior. So we can know that from what we put on C. Okay, so let's do this really quick. So we would say as x approaches negative infinity, y approaches, so as x looks left, what is it doing? It's going up. It goes up to positive infinity. As x approaches positive infinity, y approaches positive infinity. They're both going up. Look at number 2. As x approaches negative infinity, what are my y values doing? They're going down, so that's negative infinity. As x approaches the right, positive infinity, what are the y values doing? If I look right, they are going up to positive infinity. Jump over here to number 3. As x approaches negative infinity, we always start looking left. Y approaches negative infinity. Look, it's going down. As x approaches positive infinity, when I look to the right, what are the y values doing? Well, they're going down, so it's approaching negative infinity. And then lastly, number 4. As x approaches negative infinity, looking left, what are my y values doing? They're going up, so it's going to positive infinity. As x approaches positive infinity, y approaches, it's going down, so it's negative infinity. Okay, now let's go back and do the sketch part, all right? Sketch the possible graph with the maximum turning points. Now, don't get too caught up in this. We know that the two ends go up, right? We said that right here. So we're going to start here, and we know it's going to turn 3 times. So I'm going to go down 1, 2, 3. So where are my turning points? Here's 1, 2, 3 turning points, okay? Now, keep in mind, this is a function. So make yourself a note that whatever you sketch must pass the vertical line test. So be careful that you don't overlap or anything, okay? Let's try number 2. This has 2 turning points, and it starts from the bottom, so it goes 1, 2. So turn it twice. Here's 1, 2, 2 turning points. Number 3, this one has 5 turning points. Starts pointing down, ends pointing down. So I'm going to start down here. I'm going to go 1, 2, 3, 4, 5. Let's count our turning points. 1, 2, 3, 4, 5. That's my polynomial. As long as my ends match what I sketched, I'm good. And I have the right number of turns. Let's try this last one. This one has 4 turning points, but it starts from the positive. So it's going to start going this way. So it's going to go 1, 2, 3, 4. 1, 2, 3, 4. If you do the right number of turning points, you should end up mimicking what you'd put on part C, the line and the direction of your ends. All right. So this lesson has a lot of new information. I hope you caught it all and it's making a little bit of sense. All right, let me know what questions you have when you get to class. Good luck.